Section 8.1. This is a review of all our integral techniques. So you have some rules that are listed at the beginning of it, but we've already discussed those rules. So we're going to work with number 1, and it's, okay, this is a UDU, and we're going to let U be the 3 plus 2x, then the du would be 2dx. So here's my u, my du, I need to stick a 2 in there, which means I need to stick a 1/2 on the outside. And it'll be 1 over u du. Now I need to change out the variables. So when x is 2, u is going to be 3 plus 4, 7. And when x is negative 1, u would be 3 minus 2, or 1. So my values are going to go 1 to 7 now. Now the integral of 1 over u is the natural log of u. Evaluate it from 1 to 7. So that's 1/2 natural log of 7 minus natural log of 1. I dropped the absolute value bars because those are both positive numbers. But the natural log of 1 is 0. So I get 1/2 natural log of 7. And that one's done. Example 2. We are integrating e to the x, whatever e to the x, e to the negative x. Okay, now this is going to be, they're calling it a subtle substitution. We want to use a UDU, and so maybe I can get what I need by multiplying the top and the bottom by an e to the x. So I get an e to the x dx on top. On the bottom I get e to the 2x plus 1. Okay, so now if I do the substitution, u equals e to the x, the derivative would also be e to the x, and my integral would turn into, here's my u. My u is going to be this piece right here, but squared. So I'm going to have a du on top and a u squared plus 1 on the bottom, which that is an arctan of u plus the c. Oh, but I have to put back the x. So arctan of e to the x plus c. That's number 2. Number 3. Okay, oh, there's a little trick on number 3. And that's the whole problem here. You have to pick out the tricks. Since there is just one term in the denominator, we could split this into 2 separate problems. We could do cosine of x over secant of x dx plus sine cubed of x over secant of x dx. Now the first integral, if I bring the secant upstairs, that's cosine squared of x. The second one, when I bring the secant upstairs, that is the sine cubed of x cosine of x. Now, in order to integrate trig the cosine squared, the sine squared and the cosine squared, we use those half angle identities. And the half angle identity that we're going to use here is, there are 2 of them, I'll list them both for you. Cosine squared of x is equal to 1 plus cosine 2x over 2, and then the sine squared version is the same thing but minus. So we're going to use the first one. It's going to turn this into the integral of 1 plus the cosine of 2x over 2 dx. And that last one, that's just going to be a UDU problem. So I'm just going to copy it down right now. I'll come back to it in a little bit. Whoops, sine. Okay, now I have another fraction. that has only one term in the bottom. So I'm going to split it again. Now I'm integrating 1/2 plus I'm integrating 1/2 the cosine of 2x. Oops, let's put the dx's in. And this one I could change out. Let's do a u substitution. Let u equal the sine of x, so du would be the cosine of x dx. So this will turn into u cubed du. Alright, this one's easy. This is just 1/2 x. This is a little u du. I know the integral of the cosine is the sine, but the derivative of 2x is 2, so I need to have a 1/4 there. Now check it. Take the derivative. You'd get 1/4 cosine of 2x times 2. The 2 would cancel with the 4 and make it a 1/2, so that's right. This one turns into raise the power, flip it in front, and since it's the last step, I'm just going to go ahead and replace the u. So it's going to end up being 1/4 sine to the 4th of x, and then don't forget the plus c. Alright, number 4. Number 4, the numerator has a higher degree than the denominator. And we have a rule in math that says if your numerator is higher or equal to your denominator, then you need to do the division on it. So we're going to take a little step over here and do some long division. X plus 4. You could use synthetic on this one, but since I've already started it this way, I'll leave it. I need an x. I multiply back. Change the signs. That's gone. Negative 2x minus 1. So now I need a negative 2. Change the signs. That's gone. 7. So this turns into the integral of x minus 2 plus 7 over x plus 4. Okay, well the integral of x is 1/2 x squared. The integral of negative 2 is negative 2x. And then there's another natural log, so it's 7 natural log of x plus 4. And then don't forget your plus c. Alright, we're ready for number 5. Complete the square. They're giving a little hint on this one. They're telling you it's complete the square. I don't know if this is going to fit here. Let's see if I can fit it. We are integrating dx over the square root of negative 7 minus 8x minus x squared. Okay, the first thing I'm going to do with that, I'm going to take that little polynomial off to the side here, and I'm going to factor a minus out of it and rearrange it. And then I need to complete the square on it. So it's going to be, you take half of 8 is 4, squared is 16. You add a 16, subtract a 16. And there's my 7 on the end. I work with the first 3, and it turns into x squared, x plus 4 quantity squared. And then this on the end is minus 9. So I'm going to turn it around and write it as 9 minus x plus 4 quantity squared. So now if I put that back in the integral, we have the square root of 9 minus x plus 4 quantity squared. We're setting it up to look like an arc sign. In this case, we're going to set the u, I'm going to put my u down here, to be x plus 4, which means du is dx. We also have an a in this problem, so a is going to be 3 because that's a squared. The 9 is a squared. So this turns into the integral of dx over the square root of 9 minus u squared, which then turns into the arc sign, and it's u over a is 3, plus c, and then I've got to put it back, so it's the arc sine of x plus 4 is what u is, over 3 plus c.